Lesson 7-4, equations with no solutions or infinitely many solutions. You have been usually solving problems that have one solution. So there still are situations, and most situations do have one solution, but we want to introduce you to this concept that some equations will have no solutions and some also have infinitely many solutions. And in the book, I'm on page 407. I'm turning to page 408 right now. So, example 1, solve an equation with infinitely many solutions. For what values of x will the rectangle and the triangle have the same perimeter? We need to remember that perimeter is the distance around an object. So what we're going to do is look at this in two different ways. And one way is to use a bar diagram, which is not the same as a bar graph. Bar graphs look like this and have a y-axis and an x-axis like that. So bar diagrams, you are using one or two bars to represent the situations. The light colored blue is the rectangle, and the dark colored blue is the triangle. And so what they did here was they just took the values, and by definition, because this is a rectangle, opposite sides are going to have the same length. So they represented the two long sides with 2x plus 3 and 2x plus 3, and the two short sides with x and x. So if these two are going to have the same perimeter, then the bar for the triangle needs to be the same length, but notice that the parts are not necessarily divided up the same way that the parts are for the rectangle, which is okay. So they put the values in the expressions for the three sides of the triangle, because the triangle has three sides. Then what they did was they broke apart the two x's right here, and they just represented them as x and x, and then they kept the 3. They did the same thing here, x and x, and then they kept the constant 3, and then here you have the two x's. So they're showing it to you in terms of the expressions that represent the sides, and then they combined the two sides right here as 2x. Down here they did the same thing for the triangle. They broke apart the two x's in each situation, and they left the constant represented. Notice that the bars still are the same length. They have not changed their size. So down here what we see is we have the exact same number of x's when we start rearranging. We just took these two x's and these two x's and these two x's, and we put all the x's for the rectangle on the left, and we took the constants of 3 and put those on the right. They did the same thing for the triangle. They took all of the x's, 1, 2, 3, 4, 5, 6, and they put them all together, and then they took the constants of 2, 2, 4, 6. And you can see here that we have the x values being the exact same and the constant values being the exact same. So when you have that situation where your x values are the exact same, and notice you have the same coefficient in front of each of the x's, one is for the rectangle, one is for the triangle, and the constants are the same, you are going to find that no matter what value you put in for x, the two are going to be equivalent. So we say this equation has an infinite number of solutions, because 6 always equals 6. But if we put in 1 for the rectangle, and for the triangle we also put in 1, a value of 1, we're going to have 6 equals 6. If we put in 2 for the rectangle, the x value, and 2 for the triangle, we're going to have 12 equals 12. So no matter what value we put in here, you're going to get that these two expressions are equal to each other. You cannot put in negative values here because we're talking about length, and length does not have a negative value. The other way to look at this and to solve it is probably the one that you would use. You would write out equations to represent the perimeters, and then you would start solving it. So this is the rectangle right here, and this is the triangle over here. And you can see the 2x plus 3, the 2x plus 3, and then the x and the x. And here you have the 3 parts for the triangle. Then what they did was they combined like terms. So 2x plus 2x plus 2x is 6x, and they combined the constants, and they get 6x plus 6, and over on the right hand side the same thing occurs, 6x plus 6. And then the question is, for what values of x will 6x plus 6 be equal to 6x plus 6? When you subtract out the x's from each side, you get that 6 is equal to 6. So you could have subtracted out the constants on each side, and you would have gotten 6x equals 6x. And then divide each side by 6, and you will get x equals x. So no matter how you do that, you're always going to come up with a true statement here. And so when that happens, we say that the equation has an infinite number of solutions. When you get to this point, if you have a true statement, then your answer is there's not just one solution for this problem. There's an infinite number of solutions for this problem. So down here on the try it, how many solutions does this equation have? Well, we can look and we can see that this side is simplified because there are no like terms. When we come over here, we can combine like terms and we get x and 2x, and that makes it 3x, and combine the 10 and the 5, and you get 15. So that means that 3x plus 15 is equal to 3x plus 15. And again, if you do what they were doing up above, you can, let's say, subtract 15 from each side. You're going to get 3x is equal to 3x. And then if you divide each side by 3, you're going to get that x is equal to x. And that's a true statement. So when you get that situation, when you get that situation, you know that the equation has an infinite number of solutions. If you want to write out the word infinite, you may, but this is the symbol for infinity, and it's a sideways 8. So the question says, if the value of x is negative, would the equation still be true? So if this is negative, would the equation still be true? Well, let's say that x equals negative 3. So if x is equal to negative 3, does negative 3 still equal negative 3? Looking at this up above. Well, yes, it does. So if x is equal to negative 3, then negative 3 equals negative 3, so the equation would be true. Okay, so let's look at this one over here. 3x plus 15 equals 2x, and this is just what we did over here. It's the same problem. They're just having you go through it step by step. So that's the end of example 1.